So welcome back. Today we're going to continue with SQL and we're going to get into the design of databases today. So we're actually going to start making tables. Instead of just querying from tables, we're actually going to start making our own tables so that we can support whatever data that we want. Now to do this, of course in lab you have an albums database. We already demonstrated a video game database. On the pre-prepared videos, I think we use a book database. So what's left? Films, all right? Films, actors, and directors. We're going to design a small database to support all three of those. And the first item that I would tell you about database design is that it's just like object-oriented programming, object design. Semantics will dictate your design. So if I want to create a database to support films, actors, and directors, what immediately comes to mind as to what tables I should be creating? A film table, an actor table, and a director table, at least, right? I might need some other ancillary tables to bring these things together for their proper relation. But yeah, every entity that you have, you are generally going to have a table for it. And that's what we mean by semantics dictate design. Usually you have one table per entity, all right? And so in this case, we're going to design a table for films, actors, and directors. I'm going to go over here to my SQL workbench. And I've already set it up so that I'm using my database here. And you'll remember that we still have possibly that video game database, possibly that albums database. Show tables, there we go. Yeah, we've got a lot of other tables in there that are not related to the database that we're making. That doesn't matter. The albums database has nothing to do with the video game database, right? Just because there are a bunch of tables over here that are related and a bunch of tables over here that are related doesn't mean that we can't add more tables that are unrelated to those other two. So even though on CSE you're limited to one database technically, you're the one that is named after your login, you should still be able to support multiple different tables in this, okay? All right, remember that we are online. I will be monitoring Piazza. If you have any questions, post them below. Otherwise, let's go ahead and get started and create our first table. Let's go ahead and create a table to support films. Now you should have some documentation when you do your SQL. Sometimes these are called DDLs, data description language. Ultimately, you're just going to save them as .SQL files, though. They're all plain text files. So this is our first table. This table, models a film. Right. Okay, I don't know. I'll leave it like this. The syntax for creating a table is, surprisingly, create table. And we'll go ahead and use parentheses followed by a semicolon at the end here, okay? We do need to provide the table name, and in this case, this is where good style comes in. So what should we name our table? Should we name it, first of all, should we name it films? And ignore that space there, that's not really a space. Should I name it films? Is it the films table, or are there films in it? There are films in it, right? Generally, you don't want to pluralize anything, okay? One reason is because semantically it doesn't make any sense. It's the film table that contains film records, right? But also because English is a terrible language as far as pluralizations go. Sometimes you add s, sometimes you add es, sometimes you change the y to I and add ies, and add es. Sometimes it's an entirely different word. For example, person. What's the plural of person? People. Or alternatively, persons. Right? Both of those are acceptable. Don't get into that. Don't get mired in that muck. Keep everything simple. Keep it singular. I'm also going to suggest a more modern way of doing this with a capital F instead of a lowercase f. The reason being is that your tables are ultimately going to have some connection to your objects. And if you use the same naming conventions, you will never go wrong, right? This film table has a connection to my film object that I'm building in this project. Or your person table has a direct connection to the person object in your Java code, okay? So I'm going to use the more modern naming convention of using what we use in programming, right? So let's make note of those two things. Style tips, all right? All right. Don't pluralize. Pluralize table names, right? Suggestion, or the hard and fast rule, of course, is be consistent on your naming conventions, right? If you want to use an old school naming convention, that's perfectly fine, but you just be absolutely consistent about it. So the suggestion is that table names are upper camel case, right? And column names, if they correspond to field variables in our Java code, are going to be lower camel case. Right? Okay. So we actually need to define what the columns in our film table are going to be. Tell me, what is a film? How would you identify a film? A title. Okay. What else? A year? A release year? Okay. An ID of some sort? Question mark. None of this is SQL, by the way, yet. All right, we're just spitballing this. We're whiteboarding this right now. All right. Okay. What else? A publisher, as in like a producer, a produced company or something like that, or something. Hold on to that idea. I want to keep it simple. Right? A director, but a director is also a different entity, right? So we'll want to bring those together somehow. So I'm going to put in a comment here, director, question mark. How are we going to do that later? Right. I also want to know how good this film is. So maybe an IMDb rating, because that's really the de facto standard, right? If you're looking, or Rotten Tomatoes, I guess, is also a good place, an aggregate of, like we could have Rotten Tomatoes instead if you want, but IMDb rating. All right. Okay. So let's go ahead and start at the top here. How do you identify a film? Does anybody know? If it were books, it would be ISBNs, right? With films, I think it's an EIDR. EIDR. Yep. There is it's probably a company. I'm not sure if they're recognized or not, but there's a company that holds IEDR, and I don't remember what that stands. Entertainment Identifier Registry. So, for example, give me a recent film of some sort. Endgame. All right. MCM, like the Marvel Endgame, right? We're gonna get a million things about this, right? Endgame is an edit of. Is it the first? This one? Avengers Endgame. Well, that's Katy Perry, Ava Longoria, or Katy Perry. Was Katy Perry in Endgame? That's got to be something. I'm pretty. Is episode of. Well, let's go ahead and go with this. Is this it? No, this is X-Files. I mean, you're gonna. What year was it released? Do you have any idea? 2018. 2019? Yes. Okay. If we don't get it on this one, I'm going to give up and just take some random. Okay. Is episode of. Okay. All right. Is episode of Law and Order's Special Victims Unit. All right. So, I don't know. Joker. That's what I was thinking of. Hey, there we go. Is that? No. That is some Indian film released in 2013. So this is going to be hard, but in any case, you get the idea. These are IEDRs, right? There's an alphanumeric code with a bunch of periods, slashes in it, uniquely identifying these things, okay? So that's one possible way of identifying it, or if this are books, it would be ISBN. but I don't want that in my database. Those are called natural keys, right? A natural key is, say, a social security number, or an NUID number if you're a UNL student, or an ISBN or an EIDR. I don't want those controlling my database because I don't control them, right? Think about the typical situation where a student comes in and they're accidentally assigned a duplicate NUID, right? But in your system, you're using that to identify that person, and suddenly they switch their NUID, right? Chaos. So we're not going to make that mistake because if we don't control the data, we shouldn't allow the data to control us. So what I'm going to do is I'm going to create a film ID that is automatically generated and maintained by my database, okay? The way that I'm going to do this is I'm going to make it an integer, right? And it's going to be my primary key. I'm not going to allow it to be null, not null, and I'm going to make sure that the database automatically generates it, like whenever we put in a new video game or a new publisher, it automatically generated a new ID for us. We could always put in manually what we wanted, and we can do that here as well. But if we don't, then it'll automatically assign the next available ID, making sure that they're all unique. So auto increment. There we go. In fact, this is a good design pattern to follow. That every time you create a table, this is called a surrogate key because it's not a natural key. It's a key that is generated and maintained by our own database as a surrogate for that other natural key, that ISBN or that social security number, okay? And note my naming convention here. It is lower camel cased, but I simply took the table name and appended ID to it, right? That way, if you're ever thinking about making a query to your database, oh, what's the primary key again? Oh, okay, well, that's the film, so film ID must be there, right? No guesswork at all, right? It's a consistent naming convention that means that you don't really have to think about it when you're querying, okay? The integer identifies this as an int, right? Generally, you don't want primary keys to be strings because then you're relying on string matching and all the pains that come with string matching. Inefficiency, case sensitivity issues, et cetera, et cetera. So I'm going to make this into an integer because 32-bit assigned integer and a 32-bit signed integer, there's no guesswork there at all, right? It's 32 bits that you're comparing. Primary key, the 2 words, no underscore there, that uniquely, that sets it as the primary key field, okay? Not null means that nobody can ever insert data without a primary key. If I didn't have this, you could insert one record that had a null primary key, but you could never insert another record that had a null primary key. Why? Well, because primary keys are unique. If you want to, you can do that and follow some weird pattern, but I'm just going to make it not null, right? Auto increment means that we're letting the database take care of it for us. It's going to automatically increment this stuff and it does key management, okay? At the end here, we have a comma, right? So title, what is a title? Joker, Dune, Endgame. It's going to be a string, and in SQL, in SQL, a string is a variable character. Now, you can put in a length here, a maximum length. When I put in 255, that's for historic purposes. That's large enough for any reasonable film title. If we were putting in an essay, or if we were putting in, full documents or something like that, or source code for some reason in our database, we of course can make this much larger, 4096 or something like that. 255 is a very, very common value to use though, right? Names and stuff like that. Very rarely are you over 255. Now, why was 255 the magic number? Historically, it used to be based on bits, and 255 is one less, null terminating character than 256. 256 is a perfectly 2 to the 8th, and so it only requires 1 byte of addressing, whatever, right? That's no longer operable in today's world, but we still use this out of convention, right? By default, this is allowed to be null. So let's think about this. Should we allow our title of our films to be null? a missing title of a film, not yet to be named, something like that. Well, by default, if you want to allow that, go ahead. That means that you can insert data without specifying a title, and a null value will then take over. Right? Not null means that nobody can insert data without a title. You can't change a title to null, right? And that constraint will be enforced at the database level. What if we don't have? What if we want to allow them to insert records without a title, but we don't want it to be null? We can also define defaults. Default, something like this. This default value will be provided if you don't provide a title for the film. Not necessarily that this makes any sense, though, right? Of course, you could have like an empty string, right? By default, the default is null. So if it's there's the default that it's allowed to be null, and the default is null, right? I'm going to go ahead and change this so that it's not null. Okay. Release year, though, we might we might have a use case for saying that, well, it's not yet released, and then it gets delayed because of COVID. And so or it's in the early planning stages. We don't know when it's going to be released yet, right? Et cetera, et cetera, et cetera. When's the next Star Wars film going to be released? Hopefully not until they get their stuff together at Disney, right? And give everything over to Jon Favreau. If I have any influence in GME, then let me use that influence to get Jon Favreau to do everything in the Star Wars universe. Anyway, release year. Or release date. I'm going to make that a little bit more general. Okay. SQL does have support for dates. Don't use it. It is not cross-platform compatible. They are terrible. Just use an ISO standard 8601 like you're using in your project right now for a subscription, where you've got the year 2021 hyphen what is it, March 11th, the 3rd, or yeah, 11th, something like this. That's going to be the default ISO 8601 format. So let's do that. Let's go with a varchar. We don't have to go crazy though. 255. If you're using that ISO format, 4 for the year, 2 for the month, 2 for the day because of leading zeros, and then 2 more for the hyphens. So 10. Awesome. Not null. And here I will put in a default just so that you have access to the actual the syntax. Default will be 000 hyphen 00 hyphen 00. Right? That'll be our flag value to indicate that that we don't know what the release date is yet. Okay. So a variety here of ways of representing data. IMDb rating. What about that? A double. All right. Double. Right. You could also do a float, which is only 32 bits. I would not recommend it, especially for money. A double is going to have 64 bits of precision. Right. You can also, a double is actually just an alias to like numeric, like 10 and 2. This is kind of like printf style formatting, where there are 10 digits of accuracy and two digits of accuracy after the period. Right. I'm not going to do that though. Just use a double. Right. Keep it simple. Right. And if I just leave it like it is, then this means that it can be null. And if there's no Internet Movie Database rating, then I don't want a default of 0 because that says that's a terrible movie. Right? Everybody hated it. But a null value means that nobody has rated it. I want to make sure that those two things are modeled differently. So I'll leave it like this. It's nullable. There is no default. Okay. Actually, the default is the default, which is going to be null. Okay. Director, question mark. Yeah, if we end up with another a table here for directors, then I'm probably going to want to make a reference to it rather than storing their first name and the last name, etc. It's a person, right? So I'll go ahead and leave that blank for now. What are you complaining about? You're complaining about this this trailing comma here because I plan on adding more stuff there. So let me go ahead and execute this. And great, it created the film table, I should say, show tables. Right. And we see down here, right there it is, film. Okay. And I can even describe what it looks like. Describe film. And there's everything that we just created. Film ID, it's an integer. It's not allowed to be null. It's a primary key. There is no default value, and it's auto increment. Title with varchar 255, not allowed to be null, and the default is null. Release date, varchar 10, no, it's not allowed to be null, and it has a default of 000, blah, 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 right? Et cetera, et cetera. And it is allowed to be null over here. If I were to generate this eird diagram, all these diamonds would be filled in if it's not allowed to be null. It would be blank if it's allowed to be null. Right? And so if you remember back to the video game database, they had all those diamonds. Some of them were pink or red. That indicated a foreign key. Some of them were blue. That indicated a non-key value. And some of them were filled in, some of them were not. I'll show you how to generate an eird diagram by the end of today here, though. Okay? All right. Great. So let's take care of that director now. Let me get rid of this for more room. Create table, director. Right. Now, arguably, wait a second. Actors, directors, they're all people. So maybe if I just created one person table, that would be enough. And then there would be multiple roles. I would agree with that design. That's a reasonable design. But I'm trying to show you how to, the syntax and the design stuff, so I'm going to keep it like this. We could have a director and that is also an actor, that they act in their own films, right? Jon Favreau, there we go. What's this character's name in MCU? Like bodyguard Happy, or Happy Bodyguard. Is it Happy? Okay. Anyway, who cares? Create table director. Right? What's the first thing I should do? At the risk of copy pasting, every table should have a primary key value named after the table, which is an integer, a primary key, not null, and auto increment. Right? That should just be your go-to step for every table that you create. And the reason being is that it's a good database design, but two, when we get to talking about normal forms, it gives you second normal form for free. And we'll talk about normalization and design probably next week. But there's my director ID. What else is a director? First name, last name. I'm not going to go all the way with middle name, title, whatever else you might have, suffix, etc. We'll just go ahead and go with varchar here. 255 is big enough to store anybody's name. And varchar 255 on the last name. If we want it so that the last name has to be there could be, just a single name director like McG, or, yeah, is that all? Who else? Anyway, that's not even his real name, I believe. But anyway, let's go ahead and just make it so that it's not null. Right? Last name is not null, but the first name can be because there might be a single name director. Right? Or they could be using like a stage name or something. Okay? All right, that seems good enough. Let's go ahead and create that director table. And I've got green down here, so that works. Now what I need to do is I need to make reference to it. So, do I make a reference to the director ID up here, or do I make reference to what the film they directed down here, film ID? Which one of what if I did it this way first? Film ID down here. This director directed that film. That would mean that it would only have one film that you could ever direct, right? That would be the director is the child and film is the parent. So you would have a one-to-many relation, right? In other words, you could have one film that's directed by multiple directors. And that's possible. Usually the director gets fired or something. But there are films that have multiple directors, like Sin City and stuff like that. But that's not what I want to model. I just want to model the fact that the director can direct multiple films. So Jon Favreau has done several Marvel films. You got me in a Marvel mood because of, I'm not even that big of a fan, but you got me in that mood because you suggested Endgame. All right, so I don't want to do that. All right, I'm going to put the director ID up here. The director ID, the name of the foreign key, matches the name of the primary key over here. That's another good convention, because then there's no guesswork. When you join these two tables together, you join them on columns that have the exact same name. Now, there are instances in which you may want to violate that convention. For example, in your project, you're going to make reference to people. Sometimes those people are going to be salespersons. Sometimes those people are going to be managers. Sometimes those people are going to be customers. They have different roles. In which case, I would argue, yeah, go ahead and name your foreign key something different, because you can't name them all the same thing. All right, so director ID is going to match. The type also has to match. There's no sense in joining together two tables and on a string value and a numerical value, because hello has no correspondence to 1, 2, 3, 4 over here. So I'm going to make sure that they match. Director ID int. I'm also going to make sure that it's not null. If it's allowed to be null, then that means that you can have orphans, right? That you could have a film with no director in it. Right? And if you want to allow that, fine, go ahead. But I'm going to make it so that this design does not allow that. Right? It all really depends on what you're trying to model. Right? Good. Actually, now I need syntax to actually direct that this column here has a relation to this column down here. So to do that, I use the following. It's just a foreign key constraint. Foreign key director ID. Now this director ID here is referencing this field right here, because I'm still in the same table. This director ID references the director table, and within that table, it references the director ID within that table. And that's all that's required to create a foreign key reference. Now these two tables have a relationship. And because it's not null, that means that no film can exist without a director first. Right? The director is now the parent table, much like our producers? What was it? Publishers. Publishers had to exist before a film, before a video game existed. Right? Just a hint here: we're recreating the exact same database with different names. in case you're wondering if there's any difference, no, there's not. It's going to be the same basic layout of 4 tables, everything. Right? So let me go ahead and rerun this entire script now. Of course, I'll put in a to-do here. Add proper documentation. Right? Okay. I'm going to execute this entire script because I've made changes to this film table. It's not going to let me. Table film already exists. There are ways that you can alter a table. It'd end up being something like alter table film and then blah, 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 however you want to alter it. I don't want to do that. I'm setting up my database initially. So I want it all to run in one script. Okay? So I'm going to drop the table first. Drop table film. There we go. Drop table director. And then recreate them with the script down here. Right? No. Oh, okay. I thought there was a question. Nope. Okay. Now I'm going to go ahead and execute it all again. Still red. Error code. Can't create a table Seberg film. Foreign key constraint incorrectly formed. What's wrong? Yeah, the order matters, right? If I'm going to make reference to this director up here, then that table has to exist first. So let me move this up. There. Now that's the proper order, and we'll do everything. Drop table film, unknown table film. Right? Remember that it got dropped before, and it failed to be recreated again. Right? So one trick that you can use, you probably saw it in the albums database, is instead of just dropping the table, you can drop the table if it exists. Right? And then if it doesn't exist, it'll simply be a warning. Oh, I wasn't able to do that because it didn't exist. Not only that though, but if I'm creating it as director, then film, if I need to delete it, what direction should I go? Back up, right? I need to delete it in what order? If I ran this, oh, I guess, oh, I'm doing it already. I thought I figured I would do this first. This will fail. Why? I can't drop the table because I have a foreign key reference back up to the parent. Back to director is the child, right? Yeah, the child. No, sorry. The director is the parent. I can't delete the parent without first deleting the children because I would leave them as orphans. So I need to do it in the opposite order that I have. Right? And now I can do the entire thing, but it still fails. Why? Foreign key constraint fails probably because let's drop the film, then drop the director. There we go. And then let's clear this out. There. Right? And I'm only getting a warning here, yellow, because it doesn't already exist. Right? But I was able to create it and create it. Same trick that you can use here, create table if not exists. Right? Why? Because, well, if it already exists, then obviously you can't create it twice, right? Let me show you. Create table, there we go. If I try to create director again, it's going to fail with red down here because it already exists. But if I add if not exists, then it's just going to be a warning, right? Warning that it already exists, and I'll move on with the script. Okay. This all looks pretty good, right? I can run this as many times as I want, and now I've got green everywhere because I've got those conditions on this stuff. Oh, I probably need a condition over here, if not exists. There we go. Okay. No questions so far? Okay. Anybody know anything about IMDb ratings? What scale are they on? 0 to 10. So what's to stop me from putting in an average IMDb rating of -5? Nothing. So what I'm going to do is I'm going to show you what's called a check constraint. Constraint means that you're constraining the type of the type of data or the range of data, etc. We already have some constraints in here. For example, title has to be a varchar. If you insert or the IMDb rating itself has to be a double. If you try to insert hello string of varchar as an IMDb rating, then it will reject that data. So the type is already there. But if you want to further restrict the values that's between 0 and 10, you can add what's called a check constraint. You need to name your constraints, or default names will be provided for you. Let's see, 0 to 10 constraint. There we go. That it can be 0, it can be 10, and anything in between, but it can't be beyond that. And it's a check constraint. The database should check the value. If the value is IMDb rating, it must be greater than or equal to 0, and IMDb rating must be less than or equal to 10. You can put any logical condition check here that you want. If that fails, it will not insert that record. Now I'm going to tell you that I lied to you. MySQL doesn't support, actually, MariaDB, the one that you're using, does not support check constraints. The reason being is that MySQL does not support check constraints. The reason that MySQL does not support check constraints is because Oracle wants you to pay for their other databases rather than their free databases. If you are using a paid database or a sensible database like Postgres, these would be enforced. Okay? Let me show you what I mean. Let's insert some records here. So who directed Endgame? Who is? Okay. Okay. So we've all right, Anthony, you come first, so you're gonna get sole credit then. Sorry. What, Joel, you said? Joe. All right. So director ID will be 1, and you said Anthony, or last name was what? All right, Russo and Anthony. Anthony. There we go. All right. Give me another director. Well, Jon Favreau. John is Jon, right? Well, that's Favre. How do you? Oh yeah. How do you spell Favreau? We could just say Brett Favre. Favreau. R-E-A. Oh, you got it. All right. And John, Jon. Okay, good. We've got our two directors. Now let's insert some records. What I'm doing here is I'm inserting test data, right? So to make sure that not only was my table designed correctly, but I've got some test data in there that I can now actually query out and see what works. So let me go ahead and select everything from director to make sure that it worked. And I'm going to execute this entire thing all at once. So everything's being recreated on the fly so that I don't have, say, if I executed these over and over again, of course it wouldn't work because I would have two Anthony Russos as number one. So that's why I put in all of those other checks that create the table if it doesn't already exist, drop the table if it exists, so I could run this entire script all at once as I'm working. Okay. Let's go ahead and insert some test data for the movies, all right, for the films. Insert. Oops. Give myself some more room here. Insert into film. Film ID. What else do we absolutely need? The title. We don't need the release date because the default value will be provided for us. We don't need the IMDb rating because that will be, but we should, so that we can actually see that it's actually working. But we absolutely do need a director ID because you cannot have orphans without parents, or because you can't have orphans. You have to have children with parents. The way that we've designed this. So title, release date, and IMDb rating, and director ID. Right. And then values. Now remember that you can insert multiple records, right? I'm going to do this all in one shot, where we'll insert 3 movies here. So film ID, it doesn't matter. 42, right? 43, right? And 44. And then the title, we'll go ahead and go with end game. I'm sure that there's more words to that, but who cares? Jon Favreau directed what? This first one was Swingers, right? And Jon Favreau also directed what else? What? Iron Man? Okay. Iron Man or Iron Man? I think it's Iron Man, Mike. Yeah. Okay. All right, and the release date of Endgame was, I have no idea, but 2019 you said? Yep. Sometime in the summer. Let's just say January 1st. Unless you want to actually look this up and get real data. Oh, I'm sure that that's highly rated, so let's say it was 9.5, but you'd have to look that up as well. The director ID here, of course, would be, you said Anthony Russo, so 1. Swingers, I have no idea when that was released, but we'll say 1992? 01, whatever it is. I think it was highly rated, but it was also a bad movie in my opinion, so I'll make it a 4.5. And that was directed by Jon Favreau. And then Iron Man was a way better movie, popcorn movie at least, and 7.5. And that was directed by Jon Favreau there too. When was that released? Probably 2005? I have no idea. And let's go ahead and select everything from film. There we go. And let's run this all at once and see what we get. Hey, it worked. All that data is in there. Right? Now I'm doing this manually, sitting here typing. Right? Is there a better way? You already generated a bunch of data, right? Using Macaroo, or you typed it out, or something else, right? You've got CSV data. I wonder if there's a way of converting CSV data into a bunch of insertion statements. look for an easier way of doing this stuff, right? I think it would, like convertcsvorg or something like that. Literally, I think that's what it is. You can convert CSV to a variety of other formats. That's what we suggested on your first phase. You just create the CSV files and then you convert them to XML and JSON. You can also do the same thing for SQL. Okay. All right, that's working pretty well so far. What else? We want actors now, right? So let's go ahead and create another table. Create table if not exists. They're the directors, by the way. If not exists. And the table here will be called actor. Actor. Right. And I'm just going to steal some of the stuff from director because the director is a person. And like I said, if I were to redo this, I would probably only have one person table, and that person would take on several roles. When we have a director ID referencing a person table's person ID, then implicitly the role that they are playing there is as a director. When we've got a film and some sort of other table where this actor is in that film, the actor ID is referring to this person ID, then they're acting in that film, right? If not exists, sorry. And I'm going to change this so that it's actor. Primary key, not null, increment, blah, blah, blah. Okay? That looks good. If we're going to drop it, then we need to drop it up here. So drop table if exists, actor. There. We'll come back and resolve any ordering issues later on. But now how do I bring these things together? How do I bring a film and an actor together? What kind of relationship is there? Many to many, right? Endgame has dozens and dozens and dozens of actors, right? And then millions more CGI actors or copies of a CGI actor. But they've got dozens of actors. And of course, those actors are in multiple films, multiple MCU films, right? So we've got a many-to-many relation. When we have a many-to-many relation, we need a join table. This join table models a many-to-many relation between the actor table and the film table. So create table if not exists. What should we call this thing? So it's modeling the fact that this actor acted in this film. This film stars this actor. Right? So you might be tempted to give this this join table a verb name, right? But which direction do you go in, right? And that's the problem. That this actor acts in this film, but from the other perspective in plain English, that this film stars this actor over here. So you could go with acts in, stars in, right? That's kind of confusing to me. So another common way of naming join tables is just to take the two names of the tables that they join and put them together. Right? Now, who goes first, right? Actor film or film actor? Actor film actor? What do you want to name it? And this is where whiteboarding comes in. And again, in computer science, there are only two different difficult things. One is cache invalidation. The second is naming things. Right? So we could sit here and argue about this for hours. Well, I think it should be stars in. I think it should be acts in. I think it should be film actor. I think it should be actor film. Right? We could come up with a completely different name. Like in the video game database, I said availability. Right? That made sense both ways. What makes sense both ways here? Well, we can waste an hour arguing about it, or we can just design it and argue about that later on. By the way, if you take an hour to argue about something like that, you're doing something called bike shedding. And this is a well-established term in projects, but especially in software design. Bike shedding refers to the fact that it's easier to argue about inconsequential things than it is to argue about consequential things. So the term bike shedding itself comes from the situation where they are designing a new nuclear power plant, right? And they've got the design here, and it's very one of the most complex pieces of engineering in human history, right? And so it's very difficult to argue about. Well, no, I think that should be a 3/8 inch screw, or instead of a 5mm screw, because blah 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 blah, right? You have to justify things. You have to justify actual engineering questions, but you don't have to justify things like, what color should we paint the bike shed? And so that's what the committee will sit there and argue about, inconsequential things. I think it should be pink. I think it should be blue. I think it should be yellow because it needs to be highlighted against whatever, right? Who cares, right? That's called bike shedding, because you're arguing about something, you're putting more time and more effort and more resources into something that ultimately doesn't matter, where you should be using those resources and that time onto things that do matter. And the reason that it happens is because it's way easier to argue your favorite color than it is to say that this nuclear power plant has a design flaw, right? And so especially low competency individuals will like to spend longer times on inconsequential things and end up bike shedding, right? So at some point you just have to say, we're bike shedding, let's move on, right? Film actor is good enough. Okay. What's the first thing I should do? Film actor ID, int, primary key, not null, auto increment. Done. Right? Now I need to make reference to two tables. I need to make reference to the actor table and to the film table. So actor ID and film ID. These are both going to be integers, not null. And they're both going to be foreign keys. Remember, the foreign key constraint looks like this. Foreign key, whatever field you are, or whatever column you're working with in this table, actor ID, references the actor table and the actor ID in that table. See why it's so important to have consistent naming conventions? Is because I didn't have to think, what did I name that table again? Now these are simple enough tables that anybody, unless you have the memory of a goldfish, you're going to remember what we just did. But you don't have to remember 3 weeks from now. It's the actor table. And the primary key I know is the actor ID. Right? Likewise, foreign key for film ID references the film table and the film ID within that table. Don't save that. All right? There. Run it all again. Uh-oh. Can't create film actor. Foreign key constraint is incorrectly formed. Okay. What's wrong? Foreign key references foreign key. No, you're right. I probably just have an error here with dropping stuff. So if I want to drop table if exists, film actor, what order do I need to do this in? Film actor is a child of both the actor and the film. So I need to delete the children first, no matter what. And when I create it, I need to create it after both of these tables have been created. I think that this is correct. All you need to do is go in reverse order. So director, film, actor, film actor. If you want to be consistent about it, director, then the film, then the actor, then the film actor. Right? There, everything works now. Okay. We can insert some more data here. Who's your favorite MCU actor? Drawing blanks everywhere? Okay. 101. Robert Downey Jr. Oh, you would pick somebody with 3 names, wouldn't you? Robert. Oh, well, no, Junior is just a suffix anyway, right? Robert Downey. Downey? Downey? All right. 102. Give me somebody else. What do we do? Swingers, Iron Man, Endgame. Paul Rudd. Ant-Man, right? He was in the last one, right? And 103. I don't know who. I don't other than Jon Favreau. He's going to be in 2 tables now by virtue of this. So select everything from actor. Make sure that this works. There, Robert Downey Jr., Paul Rudd, and Jon Favreau. And now associate them with those films. And now you see here why I hard-coded these values. I hard-coded these values so that I could look back and that Robert Downey Jr. starred in Endgame 42. So I'm going to insert those into that join table. Insert into film actor. Now here, I don't care about that auto-generated ID at all, but I do care about the actor ID and the film ID. So the actor ID here is going to be, for the first one, sorry, there we go, 101. He acted in, what was it? 42. There we go. Paul Rudd, 102, also acted in Endgame, 42. And Jon Favreau, 103, acted in Endgame, but also he acted in Swingers, which was what? 43. And Robert Downey Jr., 101, also acted in Iron Man, which I think we made 44. Is that right? 44. Yeah, there we go. So just a bunch of numbers inserted everywhere. We can verify that by joining those 2 tables together. Select everything from film, join, or left join if we want to preserve all the films. Actor F, join actor A on F dot. Now here's the secret: no guesswork at all, right? Sorry, film actor. FA on to join the film to the film actor. Obviously, that's good. The foreign key and the primary key match. So film ID is equal to fa.film ID. And I'll go to the next line here. And then I'll join it again to the actor table, A, on. And again, no guesswork here at all. fa.actor ID is equal to a.actor ID. Run this all again, and we've got that Endgame stars Robert Downey Jr., Paul Rudd, and Jon Favreau. Swingers stars Jon Favreau, and Iron Man stars Robert Downey Jr. All right. I've got a nice little start with a bunch of test data here for this nice little simple database. Okay. Questions so far? Yeah.
So when you're doing an insert, when you in film out, for example, when you have actor ID and film ID, you could feasibly flip them around, and so long as you also flip them around.
Yes, the order generally doesn't matter. That's why you have to explicitly say that the first value in this pairing corresponds to actor ID. The second value corresponds to film ID. Did I do it the other way around? Yeah, I did it the other way around in the table, but in general, order doesn't matter. Right?
I kind of asked that because for the actor, you had first and then last name.
Yeah. That was a subconscious way of showing you that you can do that.
Oh, okay.
Very subconscious way of showing you that you can do that. Right? Obviously, use your own database if you're going to do something like this. One other thing that I wanted to show you is that remember that we had that what we called the surrogate key and the natural key. The film has a surrogate key of a film ID. That's generated and maintained by our own database. I do want to add support here for an eird. That was correct, right? eird. An entertainment identifier registry. EIDR. There. EIDR. There we go. And that's going to be a varchar. I don't know what the rules are on how long it is. but certainly 100 is big enough. Right? We can make it not null, but if we don't have it, then maybe we want to allow it to be null. Maybe we want a default of an empty string. Right? We could do a lot of things here. I'll go ahead and leave it like that. But what I do want is I want to make sure that that's unique. Okay. And the way that you can ensure something is unique is by making it a key. We already have primary keys and we have foreign keys, but there are just general keys. A key and a uniqueness constraint put together would make this into a unique field. So unique, actually, sorry, unique key. There we go. Now I'm rethinking my default there. If it's going to be unique, then how many films can have the empty key for the EIDR? Just one. And once that's taken, it's done. So maybe that default doesn't make sense anymore. Right? Not null makes sense now in this context because only one record could ever have that null value because it has to be unique. Right? All right. Let me show you that that actually does work. And let me show you that the check constraint does not work. So film. Let me go ahead and change this to 14.5. This one to negative 9.5. And we'll add at the end here an EIDR. Since it can't, we have to add it because it's not null and it's going to be unique. So ABC, XYZ, and IJK. Right, there we go. Oops. And well, that's because okay. I'm not holding down all the buttons at once there. Nope. Try one more time. Clear this out. All right. If it'll fail me here, so I'm just going to go up here. Selected portion. Execute the entire thing. Oops. Oh yeah, I misspelled it. EIDR. There we go. And now I can do everything at once. There we go. Oh, whoa! Surprise, surprise! It is actually working. The constraint on line, error code constraint failed for. Oh wow! All right, so they've updated their MariaDB instance. I take that back. That check constraint is now being enforced. Right. So let's select everything from film here and see that it actually was being enforced because everything failed. Awesome. Awesome. That's news to me. Let's go ahead and restore those. There, everything works now. So that check constraint that you saw the red at the bottom, it would not allow me to put in negative 9.5. And now it is actually being enforced. What if I, here's the film over here. All of these are going to be unique. What if I tried to insert something that does not have a unique EIDR? That's going to fail. Right? Duplicate entry ABC for EIDR. So awesome. Now check constraints and unique keys are being enforced. Right? Awesome. All right. And where would you want to do that in your project? Probably. Where would you want a unique key? Sales. Oh, so certainly a primary key should are automatically unique by default. But what else? What else should be unique? Maybe alphanumeric codes, right? That you're pulling in from the old system. Right? That would be a perfect use case for a unique constraint. Right? Let's make sure everything still works. Yep, great. Close all. All right. Any questions so far? No? All right, then. I think that's all I wanted. Let's go ahead and summarize what we looked at, right? So, style tips, design tips. Right. Always have a primary key field and suggestion. Make it an integer, not null. Auto increment. and name it after the table name plus ID. Right? That's just for consistency's sake, right? Foreign keys should have the same name and type of the key they reference, usually. Right? Again, these are guidelines and these are suggestions. Be consistent. But then consistency is the hobgoblin of small minds. Thank you, Henry David Thoreau. There are always exceptions to the rule, right? That you need to be flexible. For example, if you've got 3 keys that all reference one person, a person record, you can't name them all person ID, right? You would have to name them whatever role that person is taking on in that relationship, right? Join tables can be defined with multiple foreign keys to bring in, to model a many-to-many relation. Right? Be sure to insert plenty of test data to test your database. Right? You can auto-generate mock data, and you can easily convert existing, say, CSV data to SQL insert statements using a tool. Right? And that tool, we've got enough time that we can look it up. What was it called? convertcsvorg.com. It's not .org. convertcsvorg.com. Convert CSV to GeoJSON, to JSON, to XML. Hopefully you use those. Does it have SQL? Ah, it does. I wonder what it looks like. Right? So you don't have to do a lot of work here. Just use a tool to do something like this. Okay. What else did we notice? Oh yeah, you can use check constraints, check and uniqueness constraints. Can be used to enforce data integrity. Right? That you are, if you do not allow non-negative values, or if you do, if negative values are out, well then put a check constraint in there to make sure that that it's correct. Any logical statement that you can come up with like with an aware clause, you can make that into a constraint. What else did we do? Follow a consistent naming convention. If you want to, you can move, like, have all your data creations up here and then all your mock data down here. I interleave them. That's fine. Provide documentation. I think that's it. Yeah. Semantics dictate design. Yeah, question.
So just out of curiosity, for constraints, is it just like any kind of logic, and can you also have a constraint involving a string, for example? Or?
Yeah, you could have the length. You could ensure a minimum or a maximum. Well, a maximum length is already ensured. You could ensure a minimum length. You can ensure not null already by design. You could ensure that it's all caps, or that it's no caps. No white space. You just have to come up with the proper SQL way of expressing that. Yeah.
When the constraint fails, does it just pop up the name that you've given it of the constraint?
Yeah, so let's show it again, ABC here, and then execute this. Error, duplicate entry, ABC for EIDR. That's not the one that you wanted to see, though. The one that you wanted to see was this one. 0 to 10 constraint failed for Seberg. That's the database name, and then the film table in that database. Right? Well, then the last thing I'll show you here today is, let me go ahead and save this, untitled. Films.sql. Right. It's just a plain text file. .sql is just an extension I use to say that it's a text file. MySQL Workbench has support for automatically generated ER diagrams. So I'm going to go up to New Model. Right? That just creates this new tab up here. You can go up to File, Import, and reverse MySQL create script. Select that one that I just had on the desktop, films.sql. Place imported objects on a diagram. I wonder what that does. Right? Remember, it was not checked. Check it. If you didn't check it, it didn't create it like you showed us. That's because you didn't check it. Right? Execute. Continue. Close. Ooh. Nice looking ER diagram there. Of course, it's not going to be the layout. You're going to have to play around with it and move stuff around to get it how you want it to look. And that looks familiar. That's the exact same structure as our video game database, right? If you want to make it into a parent-child relation explicitly like this, and then two parents coming down to one child there, right? There we go. You can do it like that if you want to. Once you've got this and once you've got it looking like you want it, you can always export as, say, a PNG or a SVG, and you've got some bonus points on your design document. And you've saved yourself from writing like 3 or 4 pages of text describing your database. Right? Still describe your database, still make reference to the diagram, and describe how this database design supports the business model of the project that you're working on. But otherwise, a picture is worth 1,000 words, probably more than that. Okay. All right. Have a good weekend and make sure that you're getting, hopefully you have a fully working version that you're debugging right now, and that you are able to turn it in sometime later today, certainly by midnight tomorrow for your next phase. Have a good weekend.